We will be starting in 5 minutes. Is my screen clearly visible? Give thumbs up. Okay, so we will be first discussing yesterday's Atcoder contest. So this is our first problem, and this is very simple problem. It is stating that you are given two positive integers, which is n and m, and it is saying that we have to perform this operation multiple times till m is not 0. The operation is we will divide n by m, and each time we divide n by m, we will replace m with the remainder that we got. And how many times will we perform this operation? Till m is not 0. And it is also given that m will always be 0 after some number of operation, after a finite number of operation. So this is a very simple question. We can do this question using a while loop. So the input format is given. Just we have to take two integers n and m. So let us see the submission code. So this is very simple. Just we will declare two variable n and m, and we will take input, and we will declare one variable. Let's say operation. We will initialize it with 0, and then we will use one loop, which but this inside this loop we will make the condition while m is not equal to 0. While m is not equal to 0, we will find remainder when dividing n by m, and we will replace m with that remainder. And every time we do this operation, we are increasing the value of this variable operation. When m will be 0, then this loop will terminate, and finally we will print the value of this variable operation. So in this way, we can do first question. I think it should be clear to all of you. Okay, so now we will move on to second question. This is saying that there are two circles, C1 and C2, on the XY plane. And in this problem, whenever it writes circle, then it refers to the circumference of the circle. Okay. So it is saying that circle C1 has center at x1, y1, and C1 has a radius of r1. Similarly, circle C2 has a center at x2, y2, and it has a radius of r2. We have to determine whether circle C1 and C2 have a common point or not. So what we have to determine here is that there exists at least one point where circle C1 and C2 both share a common point. So input format is something like we are given t test cases, and for each test case, we have to take input such that x1, y1, r1, x2, y2, r2. Okay. So first of all, let us understand that in which condition can two circle have a common point. So I have drawn it here. See, if two circle touches externally, like if they touch externally, then there is one common point between them. And when can it touch externally? So what is the condition for this? So the distance between their centers will be equal to the sum of their radius. So this is first condition where both circle will touch externally, then they will have exactly one common point. The other one is similar condition. Here, both circle will touch internally. That is, there is one circle, and inside that there is another circle. So in this case also, both are touching each other. So there is exactly one common point. And what is the condition for this? Condition is distance between their centers is the difference of their radius. And the third one is both circle can intersect. Now, if they will intersect, then they will have two common points, and it also satisfies our condition that it should have at least one common point. So when they intersect, then what will be the condition? So the distance between their centers will be less than r1 plus r2. Okay. Now, so these are the condition. So ultimately, our condition is that two circles can have a common point when the distance between their centers will be greater than or equal to the difference between their radius, and at the same point it should be less than equal to sum of their radius. Now, how do we find difference between their, how do we find the distance between their centers? So we are given the center in the form of coordinate, like circle C1 has center at x1, y1, circle C2 has center at x2, y2. So what is the formula to find distance between two coordinates? So this is the formula, under root x1 minus x2 whole square plus y1 minus y2 whole square. Now, since there is a square root, so to avoid the complexity of a square root, we will solve this problem in terms of a square of distances. So this is our main condition. This is our main condition to be satisfied to have a common point between two circles. So we will do the square of distances. So we will do r1 minus r2 whole square should be less than equal to d1 d2 whole square and should be less than equal to r1 plus r2 whole square. Okay, so this is the simple condition. Now we will see its code. So for each test case, we will take input something like this. Then for to find distance, we will have to find the difference of their x coordinate and distance of their difference of their y coordinate. So we have taken a variable a. Variable a is equals to difference of x1 and x2, and we will square this. Why are we squaring this? Because to find distance, we need a square of their difference. Similarly, we will take the difference of their y coordinate and we will square them. Okay, and then I have written this as distance, this variable. So this is what? This is a square of distance, a square of the distance between their centers, that is a plus b. Here, a square, sum of their squares is equal to a square of distance between their centers. So I have obtained the distance between their centers, and what is the maximum distance that we can take? This is sum of their radius. So we will also square this. So first of all, we will find the maximum distance equal to sum of their radius, and we will square this also. Similarly, we will find minimum distance, that is difference of their radius, and we will square this also. Now we will simply check this condition, that if the distance between their centers lies in between these two, then we can say that this two circle will have at least one common point. So this is the simple condition that we are checking, that if distance is less than equals to max distance and distance is greater than equal to mean distance, then we are printing yes, otherwise we are printing no. So this was all about problem B. That is 2 rigs. Is it clear? Okay. Uh, Now we will move to third problem. Okay. This is saying that there are n pieces of sari, that is vinegared rice, and m pieces of neta, this is toppings, as ingredients for sushi. This is something we have to keep in mind, that there are n piece and m piece. Okay. The weight of the ith sari is ai, and the weight of the jth is bj. Okay. Now we will make sushi by combining one sari and one neta. To make one piece of sushi, you need to combine one sari with one neta. Here the weight of neta must be at most twice the weight of the sari. This is the main condition that we will have to keep in mind, that whenever we take one piece of sari and one piece of neta, then we will also have to keep in mind that the weight of neta must be less than or equals to the twice of weight of sari. Okay. So from this, we can conclude that every time for any pair and for any value of sari, we will try to take the minimum possible weight of neta, so that we will always have a chance that it is less than or equals to the twice of weight of sari. Okay. Also, it is given that the same sari or neta cannot be used in multiple pieces of sushi. So these are the input form. Like we will have first to integers n and m, where n is the number of pieces of sari and m is the number of pieces of neta. Okay. Then we are given n integers. We will store this in the form of array, where each integer is the weight of sari, and again n integers, which is the weight of neta. Okay. So we will take the minimum weight of neta possible. So for that, we will do sorting. Let us see the submission for this. Okay, so first of all, we have taken the input, and then what will we do? We will sort the weight array. Why are we sorting this? So that every time we will try to take the minimum possible value that we can take. Okay, and also for each for like for each element of sari, we will try to take the minimum possible weight of neta, and so we will also sort both array, neta and sari. So we will just sort both the array, and till now, like, what will be the number of times the loop will run? Like, we will initialize one pointer to the ARR array and second one to the BRR array. And what will be the number of times till the loop will run? So it is not given here that the both are having same number, that both are having same pieces. They are different, n and m are different. So every time we make a piece of sushi, so we will take one and one, both one. Okay. So we will first find the minimum of both. So we have declared an integer variable mini, where mini equals to minimum of n and m, and loop will run. Now, one thing to notice that I have written here, that we have sorted this array also and this array also. For each element of BRR, we will try to take the minimum element of ARR. Now, imagine a condition where, like, let's imagine 3 here. Now, for 3, the corresponding element is 7. But here we see that 7 is greater than twice of 3. So we know that if there would be more elements of ARR, then all would have been greater than 7. So we can't find any element corresponding to this 3. So what we will do? We will just skip this 3. But again, we will say, like, let here would be after 3, there would be 4. Then what? There should be this pointer at 7 only, and this pointer will go to next, that is 4. So here 4 and 7 will match our condition. So we can see that we are taking every continuous element of ARR, but we might skip the element of BRR. So in this loop, we are making the condition that while j is less than mini, and since we can skip some elements of BRR, so I should be less than n. And every time we check that if the element of BRR is less than or equals to twice the element of ARR, then we will count this, we will take this, and we will increase the pointer. That is, we will increase I pointer and we will increase j pointer. Otherwise, if it does not match our condition, that means that we can't find any corresponding pair for this particular element. So we will just increase the I pointer. Okay. When the loop will terminate, then we will have some value in this count variable, and whatever will the value in this count variable, this will be our answer. So this was the code for our third question, that is sushi. Okay, so this was all about yesterday's Atcoder contest. If you guys have any doubt, then you can ask me. Otherwise, we will move to CodeForces discussion.
I hope my screen is visible and I am audible also. Yeah. So I'll be we'll be discussing CodeForces Deep 2 contest that held yesterday. So this is the first question: convergence. Uh, Alice is inviting our friends to a party to eat cakes. However, each friend may not be at the same place, so everyone has to meet up at the same location first. Alice has n friends where the ith friend is at position AI. to make everyone be at the same place, Alice has to make multiple group calls. Unfortunately, the signal is weak and Alice can only call two other people at a time. Like, being a good person, Alice doesn't want her friends to walk too far. So for each group call containing ith friend and jth friend, Alice will tell both of them to meet at some integer location between min of AIAJ and max of AIAJ, inclusive. After that, both of them will move to that location so quickly that Alice cannot make any group call during their movement. Please note that Alice can call these friends again once they reach at the location. Right. The party is starting soon, so Alice need to make group call fast. Help her find new number of group calls she needs to make. So this is the question. As we clearly see, the question is too much low, so we can do a brute force approach. Let me first visualize what the question is saying. Uh, okay, suppose, okay, this is a, okay, 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 this is a, suppose, path, right? And Alice's friends are standing at some integer value, or you can say some position on the path, right? Now, Alice need to make a call to her friend and ask them to come to any common position, right? So, and she can only make two call at one time. So either, and one condition is also there. This condition that is mean, uh, you can invite the friend if she want to invite two friends, you can invite only on places between them because mean of Aij and max of Aij will be the experiments and the places between them are the places that is lying between them. So if she want to call this friend and this friend, so she can invite from this place, this place, this place, or this place. So we need to uh, take account of this also because this is the primary condition of this question. So from the intuition itself, as we clearly see, she need to invite all the friends at the common location. We can go with the midpoint, right? If I take a midpoint and try to inviting all friends, suppose first I'm inviting this to this current location and this, she will require one call. Then she will start calling the next friend that is this and this, right? So this way she can call her friends. So if I see the test cases, suppose 1, 2, 3, 4, 5, uh, yeah, I can write 1, 2, 3, 4, 5 here because as we know that the path is in sorted order. So if I take midpoint 3 here, we can similarly call her friends like I stated. First, she will call these two friends, then these two friends. So total, she need to make two calls, right? So if I see the answer, you can clearly see the answer for the first test case is 2. So now the question is how we find the midpoint. So it is simple. We can sort the array and take the median of that array. Right? So if I take another test case, suppose this one, or yeah, this one within 3K, so I will take this one. So if I draw a number line, 1, 2, 3, 4, 5. So 1, 2, 2, 2. So suppose this is 1, 2, 2. Already this is are in sorted order, so we will not have to sort this. If I take a median, that will be this number. Now she will does she need to make a call to this friend? No, because her friend is already at position 2. She is at position 2 and she doesn't require to call their friend which is already at position 2. So she will need only make two make one call that is for this point, right? So for this test, the answer must be one. So yeah, this is the answer. So if I show you the code, uh, first I am sorting the array, right? The mid is that's the midpoint of that array. If it is odd uh, or even, it will be not dependent on anything. So we'll take the mid element, and we'll be finding how many numbers that are smaller than the midpoint and how many numbers are that is greater than the number. Like in this case, you can clearly say for 2, there are only one smaller element present and no number, or you can say number, are greater than 2. So only one count is increased. So the answer will be uh, that one only. And we are taking minimum of it. Right. So like in this case, this is not required. We can easily write the we can don't like this minimum of maxi and mini is used in for brute force approach. We can easily write uh, P out uh, mini plus maxi. This will also give us answer same. Yeah. Okay. Some okay. Okay. Uh, this is fine. Yeah, you can go with this also. Okay. If you have any doubt, you can ask for this question. Fine. Let's move to another question. Cake leveling. Alice is preparing a cake for her party. However, she is in a rush, so the frosting on the cake is uneven. To quickly solve this issue, Alice will put her knife at some integer height and then sweep the frosting from left to right to make the frosting level. Formally, let AI be the height of the frosting at height position. Suppose that Alice puts her knife at some integer height at h. If the height of frosting at position I is greater than h, the excess frosting will be pushed to position I plus 1. Excess frosting on a position n will be pushed off the cake completely if it is like last index. Alice and her friends really love cake frosting since Alice decided to serve some prefix of the cake instead of the her find the max. Okay, Alice and her friends really love cake frosting. Since Alice might decide to serve some prefix of the cake instead of the whole cake, help her find the maximum height the frosting can be while keeping the frosting level for the first I position for I equal to 1 to up to n. And constraint is 2e5, which we can we need to solve in like in the O of n, or you can say n log n. So if I go to the question is we have given a cake with some indexes are given with some height. Suppose uh, first index is given with height 2, third second is given with 3 height. Then you can say again third index is given with 2 height. Okay. So yeah. So this suppose this cake is given, right? And you have a knife. Suppose I'm taking another color, let's say black. So I have a knife and I want to make cake level. So I'll be taking my knife and start cutting this. And this extra excess cake uh, will move to the next index. Now it will move to this index. And our knife is at this position. So this extra cake will be moved to the outside of the cave because here it is already filled. But if I take another case, suppose this case, uh, you can clearly see if I cut this excess cake will be dropped to the next empty space, and this cake will become level. Right? So now the question is, suppose consider a question where uh, we can cut from the both sides, right? So suppose I have a cake. Uh, I am changing little bit the question. Suppose I can cut from the both ends, and I want to make all the height level, right? So what will be the approach? Suppose this height is 3, this is 4, this is 2, and this is 4. Now, if our condition is we can cut from the both ends, and we need to make height equal, uh, we can easily add all this 4 plus 2 plus 4 plus 3. That is 8 plus 11 plus 2, 13, and we can divide it by total number of group or you can say section. That will be 3. Like if I convert it to integer, it will be close to 3. So we can make maximum height of 3 from this state. If we have a condition that we can cut from both the ends, right? This extra it will be dumped to this, and this can be maximum we can make to height. But in the given question, we can only use our knife from one direction. So if I take a test case, suppose I'm taking the first test case that is 4 to 3. Suppose 4, 2, and 3. Now, and the what the problem is asking. First, let's discuss that. Problem is asking that she can serve some prefix of the cake instead of the full cake. So she required that up to that prefix, like up to any index, what is the maximum height she can uh, she can have the cake of the height of the that up to that prefix, right? Suppose if I am giving I equal to 3, so she need to find out what is the maximum height of the cake that she can attain uh, up to that index 3. Right? So if I start with index 1, so what is the maximum height she can get? If it is 4 and second one is 3 and 4 to 3, I guess. Yeah, 4 to 3. This is 2. This is 2. Right? And this is 3. So for first index, what is the maximum height she can get? It is 4 because we can't increase the height of this section. Like we can decrease it, but we can't increase it. So the maximum height she can gain, attain for the first index will be 4. If I move to the second part, so we can consider this section, this group. Now this group can be combined, and we can use our this analogy here, right? That we can divide whole section into the number of groups, and we can find out the maximum, right? So what will be the total unit of this? Like 4 plus 2 equal to 6. And if I divide the total number of section, or you can say group, that is 2 here. So we can attain maximum height of 3. So for second index, that will be 3. Right. If I consider a whole cake, because we come to now the index third, so we can consider a full cake. Now again, if we add 4 plus 2 and 3, that is 4 plus 3, 7 plus 2, 9, 9 upon total section is 3. This will become 3. So we can make the third index up to height 3. So if I show you how we can make this take, uh, the first take is 4, third take is 3, right? So now if we start chopping from height 3, this extra cake will be dumped here. So the height of second cake will be also 3. Now for index 2, the height will be 3, and for index 3, it is already 3, right? So this way we can calculate this. But one case is there. If we take this example, like I can take a smaller example from here. Like if we have this cake, right, and suppose this cake. So how will we finding the like maximum height? So we'll be doing the same thing first. The like suppose this is 5, this is 3, this is 2. So the maximum height will be same because we can't change the height of this. So it will be same 5. For this will 5 plus 3 upon 2, that is 4. And for this 5 plus 3, 8 plus 2, 10, 10 upon 3, that will be 3. Now, if I add another section of suppose bigger one, suppose it is up to 10. Now, if I consider this whole section, our sum will become 5 plus 3 plus 2, 10 plus 10, 20, right? And if I divide number of sections, that is 4a, this will give 5, right? But we can't directly assign 5 here. Uh, this is the tricky case of this question. So we can't assign 5 because our maximum height we can attain, like minimum height we can attain is 3. So we can't go beyond this 3, right? So any answer of next index always be smaller than the previous element. So we need to take care of the minimum height, and like we need to return, or you can say print the height according to the minimum height. So if I show you the code of problem B, yeah. So first I am taking the last, that will be storing the last minimum, right? That's why I'm assigning it a very large value. And again, that I am doing is adding the sections and I plus 1 because I am starting for with 0. So this is the number of sections and the sum is the suppose the total amount of the cake on that section, right? And I am inserting that height into a answer array. Then I simply print that array. And this logic, this minimum logic is simply this one, that I am taking minimum of loss because we need to cap the height because the next uh, peak height should not be greater than the minimum. It should be below the minimum of the visited peak. Right? So this is about the second question. I hope this is clear. If you have any doubt, you can ask. Else, Somajit will continue to the next part.
I hope my screen is visible and I am audible also. Yeah, right. Okay, so let us discuss the problem C1, C2. Basically, they are the same problems, but the difference is in this constraints. Okay, so we'll try to solve it as a one go to a greedy approach. Okay, let us see. So Alice's friends have come to a party. There are X tables and S seats each. And there are three type of person: introvert, extrovert, and ambivert. Okay. So basically, the problem says, okay, we'll discuss the C1, C2 as a whole. Oh, okay. So there are X tables. There are S seats per table, and there are three type of persons. Three type of persons. They are mainly one introvert. So introvert wants to sit in a empty table. If he wants to sit, he must sit in a empty table. Suppose so this is a table and there are S seats per table. So this must be empty only when I can an introvert can sit in this. Okay. And ambivert, he can sit in anywhere, maybe non-empty or the table is empty or the table is non-empty anywhere. Okay, so another thing is extrovert. Okay, he must sit in a non-empty table. Okay, that means he needs a companion. That's why he is called an extrovert. Hmm. So if it's this is a table, there must be one ambivert or introvert must be in this table so that an extrovert can be occupied here. Okay, so we are given a sequence as a string, like we are given a string U and a sequence of persons that come to the party are like this E A A. So we need to find out what is the maximum number of persons we can sit in a table. So we are given X tables and there are S seats per table. This whole thing, there are total number of S seats. Okay. I think up to this, it is clear the problem statement. Okay, right. Let's see how can we solve this. Hmm. Okay, let's try to simulate. Let's take an example. Like first an introvert comes, then an ambivert, and then an extrovert. And there are two tables, and so that x is equal to 2, and the number of seats per table is 2. So basically, that's 2 seats available, right? Okay. So for the introvert comes, so both tables are empty. So introvert can be occupied here. Okay. Then ambivert comes. Ambivert has two choices. Like he or she can be seated anywhere. He may be seated in this or this. Okay. But this choice depends upon what we have this. Okay. For example, we have an extrovert here. He needs a companion to be seated with. So we must seat the ambivert here so that when an extrovert comes, he can be seated here. But what if the string was like this? What if that was an introvert? He must need an empty table. So we must have seated A here and here the introvert may have seated. Okay. So we saw that ambivert can be seated according to the persons arriving afterwards. Okay. Okay. Another thing is that you may wonder that I think I should discuss a sample test case. Like for this, for example, EAIA. So you can see here. I think the answer is 4. and the total number of persons 5. So one person is not seated. Okay. Third person, okay. The first person in extrovert, they have to leave the party. Second person in introvert. Okay. So extrovert has no choice to like sit in that party. Okay. So my question is that whether it is optimal, to sit every person whenever possible. Is it optimal to sit a person whenever possible? Okay, suppose I have two tables. Okay, these are all filled. This is a non-empty table. All persons are filled, occupied these seats. Okay, and this is empty. And I have two persons left, one ambivert and one introvert. Okay. Okay, if I try to sit ambivert here, then I cannot sit an introvert because he always needs a table to sit on. Okay, empty table. Okay, so if I skip ambivert, I can sit introvert. And if I sit ambivert, I cannot take this introvert. Okay, so basically, it is always optimal to sit whenever possible because in either choice, our answer would be like increased by one only, even if I have two choices. Okay, so it will not at all bother like if I am reserving these seats for introvert or I am reserving these seats for extroverts. Okay, our answer will be maximized only when we try to sit every person possible. Right. We will proceed with that only. Okay. Now let's see how can we solve this problem. Okay. So I will like maintain three variables. X that is given in the question already. It will give me number of tables. Okay. Right. Okay. Number of non-empty tables. Sorry, empty tables left. Okay. And another two variables. One my answer. It will give me the number of peoples, maximum number of peoples I have seated till now, number of persons seated. And another thing is SP. This SP means seats in an occupied table. That means in that table, at least one person is always, at least occupied table means at least one person is already seated in the table. At least one person is already seated. Okay, another most important variable that I will maintain is move. Okay, I'll come that later on. Why this important? Is this important? Okay, this is an important part. Okay, okay, let's see. Okay, suppose uh, an introvert comes. If the number of tables left is greater than 0, as I've already told, whenever possible. Okay, so my answer would be plus plus. Okay, I will sit this person as this is empty. There are number of seats available. Okay, this is empty. I sit I here. Now, what will be my SP? Seats in an occupied table. Since total number of seats is S, one is occupied, one occupied. So number of seats in an occupied table would be S minus 1. Once I sit I here. So basically my SP would be increased by S minus 1. Okay. And now my remaining number of tables, empty tables would be decreased by 1. Okay. So in that I can like makes a statement that in a table, maximum one introvert can be seated. Maximum one introvert can be seated. Can be seated. Right. Okay. I think up to this it's clear. Okay, let's go to, okay, let's say, okay, what if an extrovert comes? Okay, for this extrovert only, we're maintaining this SP variable because an extrovert can be seated in an SP position, SP seat. SP seats mean seats in, as I have written, seats in an occupied table. So if my SP is greater than 0, okay, if my SP is greater than 0, okay, so I will increment the answer. My SP will be minus minus. Right. Next one. Okay. What if okay, one important observation, like suppose this is an introvert and maybe in these seats all are person, maybe an introvert ambivert is present or extrovert, okay, here, and ambivert or extrovert here, ambivert or extrovert, okay. So it's like this. An extrovert comes, but I have a table remaining here. Okay. I have a table remaining here. Empty table. No one is seated. Now when one extrovert comes, I have no SP. My current SP is 0. Now what to do? Why not? Why not? Why not? Why not? What can I do is, what if in earlier stages I may have shifted this A? Since A can be seated anywhere, I may have shifted this A to a like this position. Okay. So it may have vacated a seat. A comes here and I can put it here. Right. Okay. I cannot move a extrovert here. Right. I cannot move an extrovert. Okay. So basically this, since extrovert can be seated only when the table is at least one person seated, that is, a table is occupied. So basically wherever A is present here, wherever there is A, I can treat this as a move variable. Okay, this is a move. Suppose this is, let me write it clearly so that it's easier to understand. This is E and this is A, this is A. Okay. So this all A are my move variable. This all person can be moved onto a new table if there are seats available. So here I can say the move is 3. Okay, right. Okay, you may wonder that I can transfer an introvert, but the thing is that in a table only one introvert can be present, right? And only one introvert can be moved. So it is my move can be at max less than equal to 1. So I don't have any vacant spaces I can create. Okay, greater than 1. So it is always like I may have a multiple number of ambiverts that I can move. That's why I'm treating these as move variable. Right. So if my x is 0, that is I have at least have one. Okay, this is if, and if SP is not equal to greater than 0, so I'll go to else if x is equal to 0, and my currently the move variables is also 0. So what can I do? I can decrement x. I have used it. My move variable is decremented by 1. I have transferred 1a to here, and now I have like increment the answer, since I have seated E here onwards. Okay. Now another thing is that since A has occupied this position, don't you think my SP has seats in an occupied table has increased by S minus 1? Okay. I'm talking about this table. Okay. Since a new person, so basically all the seats are treated as in seats in occupied table. So my SP is increased by plus equal to S minus 1. Right. Okay. So this is the case for an extrovert. Okay, let us try what can you do for an ambivert or last thing, ambivert. So yeah, so firstly, as I have discussed here, first I will check if any SP is available or not. Because if I this condition I will check first, because if I like currently check if x greater than 0, I may have used this table and it may have caused issues for an introvert. Okay. So I'm first checking if these are seats available in an occupied table. Okay. First checking if seats are available in an occupied table, then I will check for if any seats are left in this new tables, unoccupied tables or not. So if SP is 0, so what I will do, I will basically answer would be plus plus. Seats will be decreased. And another thing, as this ambivert can be moved, I will do MB plus plus. Right. Okay. So let us quickly look at the code. Okay. What I have submitted. Right. Yeah. So basically starting from I, if there are empty tables available, so my number of empty tables will decrease by 1, increase my answer, and seats in an occupied table would be increased by S minus 1. Okay. For an extrovert, I will check first if seats in occupied table are available or not. If yes, decrease that, increase my answer, or else if an empty table is left, and if any move and ambivert that can be shifted is possible, so I will shift that ambivert. Now empty tables are decreased by 1, but the seats in an occupied table has increased by S minus 1 and answer is increased. And lastly, yeah, so I'll first check if seats in an occupied table is available. So it is decreased, and yes, this ambivert can be moved for an extrovert and answer plus plus. And also if it is not possible, so I naturally I have to take this, okay, empty table, use this empty table. Number of empty tables have decreased. Now I've increased my answer, and like now the seats have increased. Okay, easily. Okay. So I hope this explanation is clear to you. And if you have any doubts, you can ask or else leave. Okay, thank you.